So hello everyone and welcome to our first webinar of 2017. To start things off this year, we are presenting a discussion on our new Archival Backup Service module. This new module was originally developed and implemented for the National Baseball Hall of Fame and Museum. Today we will discuss their use case and how the services have evolved since being implemented by a handful of other repository managers. DiscoveryGarden developer Dan Aitken again returns this year to lead another exciting discussion. As you are all aware, QA Dan is very well known in the Islandora community. He's been involved with the project in many capacities and for a number of years. Dan was a major part of the development of this new module as well. So as always, I will be recording this webinar as I mentioned, and I'll send out a link to access it later on today for anybody that is having issues. So your mics will be muted for the duration of this session to eliminate background noise. And when we reach the question period, please type your question in the chat window and Dan or I will read it out loud. So as most of you know, my name is Adam Smith. I'm the Business Development Associate here at DiscoveryGarden. I've been with the company since 2015, and I've had the chance to speak with most of you along the way. For those of you that I haven't had the pleasure of meeting yet, I look forward to being in touch in the near future. So for the webinar today, as always, we're going to start with an overview of Islandora and DiscoveryGarden. After that, I'll introduce our guest speaker, Dan Aitken, who's going to lead us through the discussion on the new archival backup services. As mentioned, following Dan's presentation, I'll open the floor to any questions. And as I mentioned, just type them into the chat window and we'll read them out loud. So with that, as always, let's begin. As I mentioned, let's start by talking a little bit about Islandora for anyone who is new to the community. The Islandora open source technology stack consists of 3 core components, being Drupal, Apache Solr, and Fedora Commons. The stack also includes a lot of utility components and dependencies as well. Islandora is a very large open source software stack and it includes many applications. So in essence, the developers of Islandora and the community that supports it are experts at integrating third-party tools into Islandora. So let's talk about the core components individually, and we'll start with Drupal. Many of you are familiar with Drupal. It's a leading open source content management system with over 30,000 user contributed modules from almost 100,000 active community members or developers. Now, active community members are vital to any open source project, and the same can be said for Drupal. People are invested in Drupal, and that leads to ongoing development and success. So Drupal serves as the presentation layer within Islandora. It's how we create a website and how we expose it to the internet. We also use Drupal for collaboration. It has a great framework for users, roles, and permissions. And we use that for workflow activities, and it really does integrate well with a lot of other functionality within Islandora. So Islandora, in essence, is a suite of Drupal modules that allow us to build repositories on top of Fedora Commons. Now, these modules make it possible to build, populate, and configure a digital repository without the aid of a developer. So next is Apache Solr. Apache Solr is used for discovery within Islandora. Solr is very powerful, very flexible, and very configurable. It's used on some of the most heavily trafficked websites and applications worldwide. Some key features of Solr include full text search faceting and filtering. It's highly scalable and fault tolerant, and provides near real-time indexing. So for example, if we ingest an object into Islandora, it's going to be indexed within Solr almost immediately, and will become searchable probably within 30 seconds after it being ingested. So the final core component is Fedora Commons. Now this is the layer that stores and preserves all of our digital content. Fedora Commons is purpose-built for data preservation and long-term data accessibility. Some key features include auditing and fixing checks, RDS XML support. We are able to scale Fedora Commons to millions of objects. It has support for virtually any file type, and it's built for interoperability. That means you can export or migrate your data in a format so that it can be stored elsewhere should you choose. So as mentioned, those 3 core components make up the open source technology framework. And we like to call it a framework as it really is the integration of components working together. Now, organizations all over the world are using the Islandora framework to build the repositories. Some of these instances are customized in order to meet specific needs, and some are not customized, as the software is very usable out of the box. People all around the world are scaling these repositories into the millions of objects, and they continue to have these large repositories perform very well. So it helps to create fast, usable sites that are meeting customers' expectations. So now a little bit about DiscoveryGarden. DiscoveryGarden is a service provider of Islandora. Now we work to remove barriers to using the open source technology We launched in 2010, and we are a partner in the Islandora Foundation, which is a non-profit entity that fosters the Islandora code. And since we've launched, we've contributed to over 90% of the Islandora code base, which we've written here at Discovery Garden on behalf of our many customers. So we offer a lot of services that relate to an Islandora repository, and a complete list of our services can be found on our website, and I'll include a link to that in the follow-up package that I send out later on today. Okay, so now on to the main discussion. It's my pleasure to once again introduce Dan Aitken. As I mentioned, Dan is a developer here at Discovery Garden and has many years of experience related to all things Islandora. Dan has led Islandora themed presentations to groups all over the world and has been the leader in many of our webinars to date. So once again, we welcome back this year Dan Aitken. Hi, Dan.
Hi. Before we get into talking about precisely what's going on with this archival backup service, I wanted to get in a tiny bit into some of the terminology that we're going to be using, because it's going to be important to understanding exactly what this is doing. So Fedora stores things in a sort of a unique way compared to a regular old file system where you would expect to be creating folders and putting files in them. Fedora stores an object as a set of XML. And the type of XML that it stores it as is this, what we call FOXML, or Fedora Object Extensible Markup Language. FOXML contains information about the object as well as information about the files or the data streams that object contains, either as the actual content of those files or as references to them. Those data streams have identifiers such as OBJ, which is the next one we have down here. In Islandora, whenever we place an object into the repository, the convention has been up until this point to refer to the original archival file that was uploaded as OBJ. And so the purpose of having a backup service is to do two things here. I mean, it can be used for other things, but in most cases, what we're archiving is the FOXML, so a complete archival representation of the object itself, as well as the OBJ, which is the actual original file that was uploaded. That's what people are trying to back up. And so in the examples that we're going to do today, we're going to work with these two different things, FOXML and the OBJ. Some of the other terminology that we're going to use. So the service that we've created here, or the modules that we've created, are sort of generic modules that simply allow you to back up to some sort of an implementation. They're basically plug-in modules that say, okay, we have the generic idea of backups, and then you can implement it however you please. And the initial implementation that we've done here is an implementation that backs up to Amazon Web Services with plans in the future to create implementations for a local file system or for other backup services as we see fit or as people deem necessary, basically. But our initial implementation is with Amazon Web Services, which is convenient for us because that's where most of the sites that we host or that we build for people are placed as well. When we talk about some things in Amazon Web Services, one of the things we talk about is EC2 or EBS. EC2 and EBS, you can think of EC2 as your actual computer, the thing that's living up there in the cloud that exists as your server that people are connecting to. An instance of it we refer to as an individual server, something that people connect to in EC2, and then EBS is storage volumes where we place data. We tend to use that as our storage service around our repositories. In addition to that, what we're using for the backup service is S3, their simple storage service. Where you can think of EC2 as a computer, you can think of S3 as just a hard drive, similar to like a USB hard drive that you might connect to your computer. S3 is, like it says, is a simple storage service. It's just a place to put information. And like it says in here, it is a fraction of the cost of EBS. So EBS is intended to be high frequency access storage, whereas S3 is supposed to be more just a place to put things, and they're supposed to live there for a long time, and you're not supposed to access them that often. So when we talk about putting the archival FOXML in there, or putting the archival copy, the OBJ in there, we're talking about putting it into S3, because those are things that your site is not really going to use that often. For most things inside Islandora, the OBJ, the original archival copy, basically just exists as a thing that you archive, and then it never really gets used by any users. It's just there's a legacy copy in there that represents whatever was originally digitized that lives in your repository. We also have in here Glacier. So Glacier is an even colder cold storage, aptly named. So S3 is supposed to be an infrequent storage service. Glacier is an even more infrequent access storage service. It's so infrequently it's intended to be so infrequently accessed that in order to get something out of there, you can't get it out of there instantly. You have to make requests to get it out of long-term storage. The upside of it, though, is that it is a fraction of the cost of S3, which is already a fraction of the cost of EBS, as well as, and this is exciting to me from a technical standpoint, Glacier has what I would deem as the most in-depth hashing that I've ever seen done in any storage service. It chunks up your file, creates huge hashes for each of them, creates hashes for pairs of hashes, creates hashes for those, and just keeps doing that until it gets one golden hash that's made out of all the individual hashes. It keeps all the individual pieces in there. It keeps them using redundant storage. It is insanely backed up. They have a recoverability rate of 99.9999 continuing percent, and I'm sure it's just that because it has to be that. You can't just say 100. But it is redundant storage that is hashed to the nines, so you know that every single piece that you're getting back is what you originally put up there. It stores those hashes, it gives those to you, and you've just got insanely good long-term storage that costs fractions of pennies to keep everything in there. Lastly, when we talk about buckets, a bucket is a hard drive in S3, is basically what you can think of it as. You put things in a bucket. Be creating buckets and putting things in them, and I'll sort of walk you through the process here of what we've done. The module that we've created is Islandora S3 Backup, and it is sort of in a very, very late stage. I wouldn't call it in beta. It's an early release right now. We've got the bare bones functionality that we'd like in there, and there are some pieces that are continuing to be moved in there as time goes on. Actually, there was an update that was released to it today to add some new functionality to it, which you'll hopefully see. I think we've got it in the test system that I've got set up. So Islandora S3 Backup, what is it? S3 Backup is an S3 implementation of our backup module, which allows you to back up and restore data streams and archival FOXML to S3. With that, S3 gives you the option to move things into Glacier over time. So you can say, okay, I've established that in this particular bucket, when I back up something into it or when I move something in there, each version of that thing, if it's been there for a week or a couple of days, move that into Glacier. It also has the ability to restore from backed up versions in S3 to specify versions or to specify a date from which you want to restore for batches of things. It also kicks off Glacier restores. So you're able to say, hey, give me a restore in Glacier, keep it there for a day, and then we'll check. You can either check back over time, or there's a cron job in Drupal that allow you to automatically pull things out of Glacier if they've been put in there, and you've requested a restore. Okay, so how does this work? This big old picture here will kind of tell you how this works, and this is actually the implementation that we did for the Baseball Hall of Fame. This is kind of what their system looks like. They have a public front-end server, and they have an ingest server that their staff uses to ingest items. In the back end, that's where the big meat and potatoes of the stack is running Fedora, your database, Triple Store, and the search engine Solr. All that stuff is working back there, but in the front end, you've got a public-facing server, and then the staff has a place to ingest things, and that ingest server is what's actually kicking off those uploads. Behind there, we have AWS with S3 and Glacier. So once something goes into Fedora, the backup module says, okay, now that it's in Fedora, also we need to send that off to S3. And then over time, the things in S3 will make their way into Glacier. So S3, we also use source snapshots of things. So we have an entirely separate bucket that takes the server as it exists at a particular time, takes a snapshot of it, and moves that into long-term storage. As I said before, Glacier is extremely secure, extremely efficient, and extremely reliable. It is, I would almost say, stupidly reliable. It does what could probably be considered right now to be an extreme amount of overkill, but in the future, we'll probably be happy that they did as much in Glacier to back things up as they do. So pretty ridiculous. Okay, so what do you need to run this module is the next part. AWS has a PHP source development kit. They have a FAR file that gets installed, and all this is in the README for the actual module. But it requires the PHP source development kit, which contains all the functionality that actually talks to Amazon Web Services. The source development kit requires PHP 5.5 or higher, so our systems that we install are usually Ubuntu systems, which means it's got to be Ubuntu 14 or later, I think, is the minimum to actually get PHP 5.5. Naturally, you need an Amazon AWS account, and with that is generated an access key and a secret key for actually logging in. Those are also required because those are part of the setup of the module. Remotely, you would need to set up buckets. And this is buckets set up in S3, and the module will actually do it for you, but it is best to actually make them on your own and simply link up the module with those buckets. That way you can sort of set up permissions in the buckets, set up, because the module itself doesn't take care of permissions. It doesn't take care of making sure that things get backed up in Glacier. It doesn't set versioning by default, so you might want to have older versions of the things you back up kept in long-term storage. A few things in Drupal that are needed. The date module is used to allow you to restore backups from a particular date, so that's nice to have. Rules is, actually, we'll get into this in a bit, because rules is really where this whole thing shines. It's really nice. Optionally, also Islandora jobs. We have an Islandora jobs module that uses gearman, which allows you to run things in the background on your server in a queue rather than having everything sort of happening simultaneously and being required right at the time that they're being done. Islandora jobs allows you to queue the backup jobs along with all the other things that Drupal is up to and Islandora is up to. That way, you don't have to do the backups immediately. It can just be done as time goes on, and you can sort of manage how much how much pressure you're putting on your server, I'll say. Lastly, the base setup includes once you install the module, you actually have to configure the access key and the secret key to make sure that you can actually access Amazon S3, as well as configure some buckets. Okay, so how do we use this? Well, actually, if I can open up a new tab, I have it's asking Adam here to grab us a new tab. I have let's see, it is called, what is it called? Local. It's just a local machine that I've installed S3 backup on. I'm going to log in here as the main user. And no, I don't want to save that. Okay, so the S3 backup module has been installed on this machine. What does that mean? Not a whole lot right out of the gate. If I go to my utility modules, the S3 backup tool is in here. There's a few options available to me. You can see there's an access key in there, but the secret key is hidden. That's because it's basically your password. There is a secret key saved, though it's not going to display. The default region you can set. There's a few other options here for uploads, downloads. The amount of time when you request something out of Glacier, it only stays in the recovery zone for a certain period of time. So how long do you want it to stay there? The longer it stays there, the more you get charged for the amount of time that it's in there. And there is an option that should be used with the greatest of care to remove data streams once they have been backed up. So you're able to say, okay, I've backed up the OBJ and I don't want to keep the OBJ here and in long-term storage at the same time. So let's purge it out of here once that's done. So that is an option that you're able to do. This just determines how long it should wait before actually trying to purge it out. That being said, if it's not backed up yet, it won't auto-purge it out. The reason it's not purged immediately is because there's not really a simple way of telling how long that OBJ will actually be needed by the rest of Islandora. I mean, it might be used to generate derivatives for things like display copies or running OCR on things. So you may need to keep it around for a little bit longer, depending on your particular site configuration. But this just says, okay, after it's been there for a day or 2 days or whatever, get it out of there. I'm also going to move over here. So where do you set up the Amazon buckets? For those of you who know a little bit about Drupal, the buckets are actually established as Drupal entities, and they have all the fancy little things that come along with entities in Drupal. They live over here in the structure section. I have 2 of them that have been set up, that I set up beforehand, a demo for OBJ data streams and a demo for just the FOXML. And if we look at this, I have actually checked the box off to purge this after backup. The server hasn't been alive for that long, so I doubt there's been an opportunity to do so. But if this lived for a little bit longer, then the OBJs would start to disappear from the repository because they've been backed up. The way you establish that you want to do it for FOXML is you just don't fill in the data stream ID, and if there is no data stream ID, it's determined to be a bucket for archival FOXML backup. So we have 2 buckets here, one for backing up archival FOXML and the other one for backing up OBJ data streams. How do you actually do the backup? Well, you go to the actual object itself. And once you go to the object, there's an option to back up an individual item, restore an individual item, either immediately if it's in S3 or to queue it if it's in Glacier. You can back up a collection and or its children. And when I say a collection, I actually also mean compounds and or their children, and books and or their children. Those are the three content types that are currently supported, though hoping to get newspaper in there sometime soon. Just haven't seen the use for it yet. I'll show you how this works in the wild. So let's go to our repository. And here's all our wonderful collections. So let's take a collection that contains things. I believe the large image collection contains things. And none of these have been backed up yet. So if I manage this collection and go to backup, this is the generic backup module that just says, okay, do we have any backup commands out there? Is there anything that we can do with this particular kind of object? Well, yes, we can. There's 3 different things that we can do with the S3 module enabled. We can back it up, we can restore it, or we can delete backups. So I'm going to hit backup because there are no backups for this collection right now. We're targeting a particular bucket. In this case, we're targeting the bucket to back up OBJ data streams. And we need to target an object of some kind, either the object itself, or if it's a collection or a compound, we can target immediate children of the object, or both the collection and immediate children of it. So let's just do that. So I select that, and it kicks off the process of uploading those objects to S3. So we've uploaded one, and the other one is really big, apparently. It exists in 38 different chunks, so that'll take a little bit to upload, but that's fine. But the initial backups or manually backing something up is honestly as simple as that. You just go to it and hit the backup button in the management page, and off it goes. While this is running, I am going to, that's not the button, that's what I want, command click. There we go. I'm going to go back to the front page, and we're going to go back to there while it's backing up. I'm going to go back to the large image collection and hit manage here. So we now have backups for one thing. I believe the last thing that was uploaded, so we're uploading children's large image collection. So the smaller one would have been uploaded. I believe the first one in the collection. Actually, if we just go right here to the collection itself and hit backup, we can see an option to restore the children of it. Submit that. So there's a few different objects here, or options here. We can target the object itself, which currently no versions are found for it. If no versions are found for a particular thing, it just won't give you the option to restore it. Any children of it, however, there are backups for the children now because we started that process. This is still running, uploading part 25. That's lovely. So with the batch parameters, we can say 2 things. Either we're going to initiate restores for items in Glacier, or we're not going to do that. That's optional. And the other thing is that we're going to target a date and a time. We're going to say, for example, I want, and it targets the most recent version after the selected date. So I can target, let's say, January 5th of 2016. I want the first version that I find after January 5th, 2016 at midnight. And this is almost backed up, so we're almost ready to initiate a restore for this if we'd like. 7. And there we go. Okay. So we initiated a backup for both the collection itself and for its children. So 2 different backups were initiated here. This top one is the one for the collection itself. You'll see it says 1 skipped items. That's because the collection itself doesn't actually have an OBJ data stream, so nothing actually gets backed up for it. However, the 2 children of it do. This completed 2 items. The 2 children do have OBJ data streams, so 2 items were uploaded. So we now have 2 backup items in our bucket. And actually, if we look at an individual, I'll just show you what this looks like for an individual object. Manage, backup, restore. I don't believe I have versioning enabled for this bucket, so it's just going to say that it's going to say that it's non-versioned. But you can see this is the backup that we made. Oh my goodness! Well, this is obviously the big one because it's 188 megs. I may not restore that one. That might take a little bit of time. Let's see here. Non-version. I'm going to go to the other one and restore it because this one is really, really big, and I don't think I should be doing that. I've already spent enough time backing up the other one. This one's much, much smaller, though. So I'm going to head to backup and hit restore. Submit that, and we have non-version 4.5 megabytes. This object, we're going to restore the OBJ. And any second now. Downloading should be much faster, hopefully, than uploading. There we go. So restore the OBJ. In the process of restoring the OBJ, if derivative creation is turned on, it will also recreate the derivatives from that version. So if you don't want that to happen, you may want to turn derivative creation off for the site. But currently on my site, derivative generation is turned on. So not only did it download the OBJ from the backup, but it also initiated derivative creation and created new versions of all those derivatives for this particular object. It's the same thing with doing the collection. It just does it in a batch over both objects. It does it in a batch no matter what you do, and it kind of has to do it in a batch because you're downloading little chunks of the file. You know, what if you have a 188 megabyte file? You don't want that to be running forever. So it downloads little chunks of it, assembles them back together, and attaches them to the object for you in a nice, clean fashion. This is all the, and it works the same way for collections that it does for the other types of objects that are currently supported. That's how the actual interface works for doing manual backups and restores. But the big question is, what about for just when you're uploading something? Do I have to go in and manually initiate backups for a particular thing? Well, the answer is yes, out of the box. You would have to manually initiate backups and restores of things. However, that's not necessarily the case if you're using rules. We've implemented rules for this particular module because it's really, really, really convenient to do so from a Drupal standpoint. I'm going to go to the rules user interface and just show you an example of how this might work. Rules is used, for those of you who don't know about or who are not familiar with the rules module, rules is used to take action when particular events happen. When something on your site happens that's compatible with rules, rules will trigger and say an event has happened of this type. And you configure and establish rules that say, okay, when that particular kind of thing happens, possibly based on these conditions, I want you to do this, this, and this. So we've implemented rules with the Amazon backup stuff because it gives us really, really granular control over the way that we allow backups to happen, or the way that a site manager allows backups to happen, or what happens when a particular thing is backed up. Flip over, I may as well just scroll down here. Flip over to the next slide here. The rules user interface is a separate module. What's giving me this interface right now is a separate module from the actual rules module. So if you want the user interface to be with it as well, you need to enable both rules and the rules user interface so that you can actually establish and create rules, just so you know. An update to the module is soon to be merged that introduces sample common rules configuration. So if you like, once we publicize this, you can see there's a pull request currently in that contains some base rules that you can go and take a look at. Rules can be imported just by copying and pasting rules definitions into a little window in the rules UI. The actions that we have, so there's actions and reactions in rules. We're able to react when a data stream backup has completed, and we're able to react when a FoxMol backup has completed. We're also able to take action of backing up a data stream or backing up archival FoxMol. So for example, I'll be answering the questions at the end of this, but I'll mention right now that I absolutely agree with the sentiment, and we'll get into why it is the current way that it is at the end of this, and also that one of the updates that I would like to put in really is the option to say before or after, because I'll just get into it right now. I mean, there's going to be time at the end, but the question that was asked is that backups should be made before the most recent version rather than after. And the reason that it's implemented as after is almost solely because that's how we implemented it for the Baseball Hall of Fame. Baseball Hall of Fame wanted the module, and so we made it, and we made it as generic as possible, but some of the things that we did were due to their specifications. And some of the things that we've added in it afterwards have been from other organization specifications, but no organization specification so far has said make backing up happen before a certain date. But good gracious, I would absolutely love to get backing up before a certain date in there, because honestly, it makes more sense to me as well. But it'll happen over time. All these little features that we're going to add in there. One of them in the works is before or after a certain date. Anyway, 2 rules. I'm actually going to set up a rule for you. Yeah, exactly. It's that's kind of, I mean, this module was initially uploaded to GitHub almost a year ago. And since then, it's had active development on it over the year. We've added a ton of features into it. And I mean, beforehand, you couldn't really do anything through Drush. You had to do everything through the user interface. And now there's Drush scripts, and your systems operators can work on things, and there's all sorts of different neat things in there. And we've expanded the rules and made them more fancy. So it's gotten much better over time, and there's more stuff that we'd love to add in this. So that'll just happen over time. Over to rules. I want to set up a rule for all of you, because I'd like to show you how this works. So let's say that somebody in your organization uploads an image, and you want that image to you want that image to you want the original OBJ of that image to be backed up. How do we do that? Well, we do that through rules. And what we say that we're reacting to, let's just give this a generic name, image backup. This could be more genericized than this, but I'm going to do it specifically for images. We're going to react on a particular event. And the type of event that we're reacting on is that a data stream has been ingested. That's what we're looking to see happen. And the particular kind of data stream that we're looking for that's been ingested is an OBJ, and it's on an image type object. And we're going to go through this. So I'm going to save this new rule that we've created. So when a data stream is ingested, we want to back it up. And that backup is conditional. I'm going to add a couple of conditions in here. When we make a rule that reacts on something happening with a data stream, we get information about the data stream in rules that we have to use and to look at. So we also get information about the object as well. So I'm going to look for a couple of things in here. We're going to say that a list contains item, and we're also going to check the object for the existence of the data stream. I'll do this first because it's a little bit simpler. So we're saying, what do we have access to? We have access to the object that was ingested or worked with and the data stream that was ingested. So we want to say that, and what information do we have in the object itself? Well, we have a list of models. And what I want to say is that in this list of models, we have, what are we looking for? Islandora, solution pack, I think here's the content model name. I'm going to do a quick double check of that because I am not 100% confident in that. So these are our base objects that we have in the system. We have basic image content model. Oh, good. I was not crazy. Excellent. So first condition we have here is we look at the list of content models on the object that we're working with and we say, is it a basic image? If so, yes, super. Let's continue. Do I need the colon at the end there? That might be what I need. Or possibly I'm doing the wrong thing here. Am I doing the wrong thing? Object. We have an object and we have content models. Let me take a look at the actual. Oh, we don't have the object, but we do have the data stream parent models. So lucky us. I'm just going to paste that. Data stream parent models is exactly the same thing as the object itself, so we'll use that instead. Oh my goodness. Are we using the right type of condition? Let me keep doing these things on the fly. The available conditions include the object namespace. They include the ID of the object, so you could potentially drill down to say, okay, is the namespace contained inside that particular thing? So we're looking inside the object models. Oh, this is why, okay, we're looking inside the object models and we're looking for, I'm going to direct input solution path. This, there we go. A little less crazy. So we're looking to see if this is a basic image content model. And I'm going to also add in, we're going to check for the existence of a data stream. The object needs to have an OBJ. That's what we're looking for. Save that. So we're talking about a basic image object that has an OBJ data stream. And the action that we're going to take is, in our Islandora backup section, we are going to export a data stream to Amazon S3 or Glacier. And the object whose data stream we want to export is object. And the data stream we want to export is the data stream that we just ingested. It's that one right there. And let's save this. There we go. Okay, so now we have a rule in place that says if I'm going to save changes to this right quickly. There we go. When a data stream is ingested, if the type of object that was ingested is a basic image, and if that object has an OBJ data stream, and I'm going to add a third condition here just to check that the ID of this data stream is correct, because right now it would upload all different types of data streams. But instead, I am going to do a data comparison on the data stream ID to make sure that the data stream ID is equal to OBJ. Save it. So now we have a rule that says when a data stream is ingested, check to see if it's a basic image. Then check to make sure that an OBJ data stream exists. And actually, we probably can remove this because these two data comparisons are pretty similar. But we're doing a data comparison to say, okay, the ID of the current data stream that was ingested is OBJ. Export that data stream to Amazon S3. And by virtue of the fact that we have a bucket that is specifically made for backing up OBJ data streams, it will know that it's the right bucket and it'll put it into the right place. Let's save those changes. We've got a little bit more to talk about here, so I'm not going to demo this quite right now. So I would like to talk about a couple of things. You'll notice that we've only made a rule that happens when a data stream of a particular kind is ingested. If you want to, I'll go back to rules to show you there's a couple of other things that you can possibly put in here. You'll notice that the event that says that a data stream is ingested is different than if a data stream was modified or a data stream was purged. So currently, our rule will happen when a data stream is initially ingested. However, if you want the backups to happen every single time you make a change to that OBJ data stream, there is a data stream modified rule here that says, okay, this data stream was modified, back it up again. Same thing with object. If you're doing the archival FOXML, you should do it on object ingested initially, but also you may want to have a rule that functions on object modified as well. So you're creating multiple versions of the archival FOXML and you're backing them all up. You'll also notice that there's a couple of other rules here that say do something when a data stream upload is complete or FOXML upload is complete. I'm going to click on one of these right now, and we're going to make a new rule, email on upload completion. So this is an example of a rule that says do something when the upload's actually completed. This allows you to sort of streamline your whole workflow through rules. You say, okay, once we've ingested something, back it up. And then once it's been backed up, do something else. S3 data stream upload complete. Let's add an action in here that says to email somebody. We're going to send mail to, where are we going to send it to? Well, we actually have a couple of things we can do. The administrative email address for the site, let's send it to them. That seems appropriate. Send an administrator a piece of information saying that something's been backed up. We also have the option to load the owner of the object, who is a Drupal site user, and grab their email as well. It's a little more complex, but it is possible. These are all things you could do with rules. What do we put as the subject? Backup complete. And then mail's message body, we can put some other things in there. Now, you'll notice that as parts of the S3 bucket itself, we have some information, and as well the key. This is the actual, you can think of it as the location of the file that was backed up. This is the location of the file that we just backed up, that OBJ data stream. We also have the URL of the bucket. So it's actually possible if you put the URL of the bucket and the key of the thing that was uploaded together, you can get the URL of the actual object, or of the actual backup in Amazon. You can also determine the status of the buckets, status and module. There's a few different properties of the bucket, whether or not that bucket is supposed to do auto purging, whether or not that bucket has a particular data stream ID, the label of the bucket. I'm going to use that. We're going to use the bucket label. Let's stick that in there. Backup completed of, let's say, bucket BSID of object ID to buckets label bucket label, and then we'll put buckets URL / key value. Oh, what does this all mean together? It means backup completed of bucket DSID would be OBJ if we backed up the OBJ. Backup completed of OBJ of whatever our object ID is, or we could also use object label. To bucket label, in our case, bucket label is, I think I did test OBJ or demo OBJ or something like that. And then this would be the full path to whatever we backed up. So s3.amazon.aws.com /bucket name /key / a whole bunch of things. You could use this as an actual URL that you can click on to see the backup itself. I'm going to save this. There we go. Missing parameter for message. Oh, I put all this in the from field. Why would I do that? Let's try that again. Okay, so now we also have a rule that says whenever a data stream upload is completed, send a mail to the site-wide administrator informing them of it and put a little information in the body of the message that says something about the backup that was made, where it went. I don't know, you could even put a time in there. Although I'm not sure why that'd be super important, but you know, it's all kinds of stuff you can do. I'm going to shut up about all this configuration and how it works and stuff like that for a minute so that we can get to the last part of this, because I want to get to answering questions because there's a bunch of questions in there. I'm going to hand this over to Adam. He'll
Yeah, so before we move on to the questions portion that Dan mentioned, I just want to talk a little bit about the implementation costs that we've seen with this module. So typically implementation ranges between $5,000 and $7,000, and that depends upon specific configurations that need to be done while implementing. We've seen a potential savings of between 20 and 25% per year on hosting costs when implemented. So it's nothing to overlook. It's significant savings. And in a lot of cases can be recouped on the initial investment within 1 or 2 years. But as I mentioned, this is all done on a case-by-case basis. So what I'll be doing afterwards in the next couple of days is reaching out to everybody individually and looking to speak about interest in installing this module and moving forward with what we've discussed here today. So I see a question popped up here. So it's time for questions. So I'll pass things back to Dan.
Yeah, if you got more questions, pop them in there and I'll start going over them. So first question was regarding newspapers. It's not that we haven't seen a use for it. It's that nobody's asked for it yet, pretty much. Newspaper is one of those underutilized modules, so we basically made it function with everything else first, because getting newspapers backed up would mean like getting the newspaper and then all the issues and then all of the pages in all of those issues backed up, and there's some crazy recursion that has to happen there in order to get that done. So we just haven't implemented yet because it's not an easy, you know, one-line thing to do. But it's on the docket eventually. It'll get in there. If you want to, for now, actually, we should add issues in there because for now, it would be possible to back up the individual pages of it. I don't think it would be possible to go to the issue and say, I want to back up all the pages of it. That currently functions for books, but not for newspaper issues. But putting it for newspaper issues would be pretty simple. We talked about before the restoration should grab the most recent version before the indicated date. I agree with that. It just hasn't been implemented, but it would be super simple to implement. It's just one of those things that's on the docket for the future, unfortunately. But definitely, absolutely agree with that sentiment, and hope we get that in there soon. Do the available conditions include the object namespace? I got into this a tiny bit, but to expand on it, they don't include the object namespace. However, it is possible to make a rule condition that checks the object identifier. So you can basically say, well, does the identifier contain does the identifier contain the namespace and colon in it? And if it does, then filter it down on that particular condition. So it would be possible to do that. Is the code repo public? Not at this second, but very shortly we intend to make this public because I mean, gosh, I would like some feedback. Good gracious. I'm not sure what percentage of the code I wrote for this, but it is a high percentage, and I will say it's been kind of a baby over the last year. So it would be beautiful to have some contributing commentary and just get it out there wide public. So I want that to be shortly. And yeah, once that's public, follow-up email, absolutely. After backup, rather than deleting the local OBJ, is it possible to change it to a different Fedora control group, specifically from externally referenced content? Unfortunately, you can't change the control group of a data stream after it's been ingested, at the very least using Took. So from the Islandora side, you can't do that. You actually need to purge the data stream and then re-ingest it. As a matter of fact, though, I do have a sample implementation sitting in GitHub somewhere that does exactly this through rules. Once it's backed up, it purges the original OBJ and replaces it with a reference to an external reference containing the bucket URL and the key value. So I should probably, I think that might be in my gists, but I'll have to look into making that public too. That might be a good candidate for something to add into the proper module. I definitely absolutely agree. It's a good idea to have that externally referenced data stream in there. Really nice addition. Is there integration with checksum checker? There isn't integration with checksum checker currently. You do get a checksum from what you put in S3, but it's a pretty weird checksum. It's a very weird checksum. It's an Amazon, and there's documentation on how the checksum is constructed. So it's not like it's Amazon's proprietary checksum. It's basically just a big combination of a whole bunch of different checksums using public algorithms. So that's what goes in there, and it's not currently compatible with checksum checker, and it's not even compatible with Fedora. It's just its own thing. But absolutely, checksum checking is another thing that's on the docket. Glacier actually checks checksums regularly and restores from backups if it finds anything that's gone wrong. But the ability to initiate that restore manually by checking checksums against what's up there would also be a really beautiful addition, I think. S3 is unable to take snapshots. Can we take a snapshot using the backup service? That's a sort of a separate thing. We can take a snapshot of the entire site as it exists, and that's good for huge disaster recovery. But for recovery of individual items, there's no real snapshotting. It's not, can't really take a snapshot. You can only upload individual files and then restore from individual files. So for most of our solutions, we do both. We have one bucket that we put snapshot, like disaster recovery snapshots into, and then we have other buckets that we put individual, like archival, voxel, and OBJs into. That way you have a disaster recovery backup, and then you have more granular backups of individual items as you need them. For user access, when items are being accessed out of Fedora, they're being accessed out of EBS. So users will typically access items out of EBS. That's why typically for our modules, we don't give access to the OBJ data stream. We say OBJ data stream is way, way, way too big and shouldn't be served up over the internet, so just don't serve it up. So we send the huge archival files off to S3 and users don't access that. And then the smaller content that's ready for users to view, like the viewing copies, the extracted metadata, anything like that, that exists in EBS for the more frequent access. Lastly, interested in exploring local file storage options. With the S3 backup, we'll also have to release the regular backup framework module. I am also interested in exploring local file storage options. That was one of the things we spoke about a year ago when we were initially doing the scoping for this task. I would absolutely love to see local file storage options, and I know that other people would love to as well. So once S3 is in a beautiful place, I think that's the next place that S3 or that Islandora backup will be going, is to local file storage.
All right, so that's it for questions for this month's webinar. But before we sign off for the month, I want to talk about an upcoming event that we're hosting at the Code for Lib conference in LA in March. The session is titled Islandora in the Wild, Training and Resources from Pilots and Production Repository Projects. So the workshop is going to cover topics such as single-site and consortial repositories, metadata wrangling, content modeling advancements, batch ingesting content and discovery, and harvesting. All examples will be taken from both pilot and production repositories. Participants will leave with an understanding of the Islandora software framework and community, the underpinnings of Islandora content modeling and metadata requirements, the ability to batch ingest content, and the knowledge of how to expose repository content to search engines and aggregators for discovery and reuse. You can visit the Code for Lib website for more information, and we hope to see you there. So thank you again to Dan. And we have one more question. Yeah, we'll fit it in. Go ahead, Dan. Can you give us an idea of the AWS hosting costs, for example? What would it cost to keep? It's going to be a case-by-case basis, and I'll follow up with the information package after this the webinar, and we can address individual questions with regards to costing at that time. So thank you all again for attending the webinar, and as mentioned, I'll follow up with some information, and I'll be following up to chat about this module. But in the meantime, if you have any questions or concerns, please reach out to me, and we'll address them as quickly as we can. So on behalf of everybody at Discovery Garden, thank you for attending, and we'll see you next month.
Thank you.